So see here, which statement is true about the factorization of 30x squared plus 40xy plus 51y squared? So it's 30x squared plus 40xy plus 51y squared. Okay. So take a moment to think about this problem. Again, you're given four options here. The factorization of 30x squared plus 40xy plus 51 squared is 10, and then 10 3x squared plus 4xy plus 5xy. The polynomial can be written as a product of a trinomial and xy. The greatest common factor of the polynomial is x squared y squared. The greatest common factor of the terms is 1. So what is true about the factorization of this? Okay, so let's break this down into, let's look at all the multiple choice here. So let's look at A here. So A. So it says A here's a factorization of 30x equals this thing here. So it's 10 times 3x squared, x squared, 3x squared plus 4xy plus 5y, right? Or y squared. Okay, so if I factored and use distributive property, I would get something like this. I would get 30x squared, because I'm multiplying it by this. 30 times 4xy would be 40xy. And then 10 times 5 here is 50y squared. So 30x squared plus 40xy plus 51y squared is not equal to 30 squared plus 40xy plus, because this here, right? 50y squared versus 51y squared. So in this case, option A is incorrect. So A is incorrect here. Okay, that's fine. Let's look at option B here. So B here says that the polynomial can be rewritten as a product of a trinomial and xy. So let's get back to this one, because I could do the work to look at the trinomial here, but I'm going to do C and D first, and maybe use process of elimination. Let's get back to B here. So let's go back to B here, and let's look at C here. So C here says the greatest common factor of the polynomial is x squared and y squared. So in this case, when we talk about greatest common factor is x squared and y squared, it's actually not correct, because what it is I have here, if I look at 30x squared plus 40xy plus 51y, x squared and y squared it's not common for all three of these terms, right? Not all of these terms have x squared and y squared, right? So if I factored out x squared and y squared out of this thing here, I wouldn't, for example, my first term here, 30x squared doesn't have a y squared, 40xy I'm missing x and y, and the 51y squared I'm missing x squared, right? So C here is incorrect, because not all terms have, and then x squared, y squared, right? So C is incorrect. And D here, the greatest common factor of these terms, 1. D here in this case is correct, right? Because the only thing common between these three terms is 1. So this here is actually correct here. So let's go back to option B. B here is incorrect here. And why is B incorrect here? The polynomial can be rewritten as the product of a trinomial and x and y, right? And what I can do is I can actually, if I were to factor this trinomial out, I would get basically some number times x here, times x plus, and then I would get some xy and then some y, right, to get a perfect square trinomial. And so it's not rewritten as trinomial and xy in this case, because a trinomial you would get something like this. It would be like ax squared plus bx plus c, and then it would be multiplied by xy, right? Which makes no sense, because if you multiply these two, you would get ax cubed plus ax cubed y plus bx squared y plus cxy, right? Which makes no sense, right? This here does not equate to my 30x squared plus 40xy, right? Because this here the degree is 3, this here the degree is 2, which means B is also an incorrect answer. Which means the only answer that's correct here is D, right? Greatest common factor is 1 here. So in this case, D is correct, and that's what they wrote here. Option D is correct, because given this, good. Option A, yes, 50 compared to 51. That's what I did over here, which is correct. Option B, there would be a y and in each of the terms, but this is not true. That's also correct here because I have a y and a y here. And greatest common factor is not it. That's good. And option D is correct. Sweet. So great. This is a good good solution, and step by step, and step by step. So that's good.